Hello, everyone. Welcome to the presentation by Group 21 for CS 6310, the Summer 2021 session. The purpose of this recording is to demonstrate the Streaming Wars implementation. So just a brief project overview. We're going to go over the architectural design improvements, the key highlights of the project, metrics and testing, feature enhancements, and a project demonstration. So on the architectural design and improvements, our group was assigned to enhance a specific implementation from assignment A3 in the scalability perspective. And in addition, our group also chose to unanimously improve the authentication authorization aspect of the system. To meet our scalability requirement, we have chosen to implement REST APIs on all of the existing transactions. And we also followed solid principles to help modularize our code base. And for authentication authorization, we use JWT tokens to authenticate the user. And we also created a sign up process and a sign in process. And we also segregated the different applicable roles of the system. So they comprise of like a subscriber role, an admin role, demographics representative, a streaming representative, and lastly, a studio representative. So first, we're going to start with scalability, and looking at the class diagrams can really help see the scalability of the system. So this was the class diagram for assignment A3. And in this design, the software modules were overly intertwined, which made it really inflexible and rigid. Some classes had too much information, such as like this monolithic class here, which made it more difficult for the system to pinpoint errors while also hurting the cohesiveness of the apparatus as a whole. Like whenever we create an event, for example, the event constructor initializes an instance of the studio class, and then every event is then instantiated with the studio. And the problem with this approach is that it tightly couples these two classes together. The updated class diagram follows solid principles. So things such as signal responsibility principle are implemented to help bring the scalability of the system. It makes our code easier to understand, easier to maintain, and much more reusable. It also uses, dependency and version patterns and stuff like that to help make creating things like events a flexible and extensible routine. And we combine this solid compliance system with the RESTful web services. The RESTful web services help leverage statelessness and multi-threading, which helps scale the APIs to a large number of concurrent users by deploying it to multiple servers. And when RESTful APIs are correctly implemented, the transactions that occur follow ACID principles and they're stateless by nature. And after the request has been served, the server does not store the data. And since REST services are cacheable, they can be used to cache the data for increased throughput. So this is the updated class diagram that follows the principles. And the sequence diagram here shows the layered approach that we followed. You can see the solid principles implemented, the REST principles, the MVC present. And this sequence diagram is for watch event, and you can see, the multiple layers that each request goes through. So now we move on to the authentication authorization part. So this goes over the sign-up process. So we use JWT authentication to demonstrate the authentication authorization enhancement. So users can sign up and create a new account in the system using like your username, email, password, and your user role. So the way this works is that your user would like submit a post request, and then the authorization controller will analyze it, see if there's anything in the user repository. If there is something already, it'll like have this error like username already in use, email already in use. But if it's not, it will create a user. It'll set the role to the user, save into the repository, and then register the user successfully. And then there's a sign in system. So once they're successfully signed up, they have to go into the sign in process. So this returns like a JWT response with a valid token. So bearer tokens were retrieved once the user signs in, and that token is passed in every request. And this token needs to be passed in all the API requests in order to interact with the system. And a legal JWT token must be added to the authorization header to validate security. And we also used a Spring security to help implement authentication authorization. The authentication request is first handled by the web security configure adapter, and it validates the username, password, and token using Authentication Manager. And we also use a layered architecture here where the requests flow from the authorization control to the authentication manager to like user detail service. And the Postgres database interaction is taken care of with the user repository and the role repository. And based on like the operation and valid credentials, the user receives a success or failure response. And we also used a password encoder for the authentication provider. And initial roles for the system are created within Docker using like the Docker startup. And these roles are added into the role table using init script, which is specified in the Docker compose.yml file. And we also implemented user role segregation so that specific users only have access to certain methods. We created an admin user that has access to all of them, but we made sure that like our streaming services representative only has access to things that relate to the streaming service. So that's why they only have access to create, stream, offer movie, offer pay-per-view, display stream, display offers, display events, display time, update, stream, and retract movie, because those are the ones that relate to streaming services. And this is applied to all the other users. So like studio representative is only have access to things related to studios. The demo representative only has stuff related to demographic groups, and the subscriber only has access to things related to the subscriber user. And this having these limitations helps increase the security of the system as a whole. Then this is the deployment structure of our system. So first, from our PC, we're gonna put in like a make request to create a Docker image, and the Docker image will then be created with 4 different containers, like your web app, your database, your PGAdmin container, and your front end. And then your web app, which contains like your streaming system, will interact with the client browser through HTTP and HTTPS requests. And based on these interactions, your database will be updated, and then you can use your PGAdmin container to check the database. So the key highlights of our project, we're able to modularize our code by implementing solid principles and REST APIs to help with horizontal scalability. We're able to authenticate users by using JWT tokens and passing these bearer tokens, and we're able to segregate different applicable roles in the system. Next is the metrics that we use to test our system.
Hi everyone. I'll be going over the compliance part for our architectural enhancements. Our first instructor assigned criteria is scalability. So we are running a Docker image, and we have these 4 containers. We have backend, PGAdmin, frontend, and the PostgreSQL. As we have already demonstrated how we have restructured and refactored our code, we are focusing scalability using changing the architectural principles and applying REST-based architecture and using solid principles. So let's go over the benchmarking, what we have done to measure our scalability portion. So I'll be using Postman to make API calls, and we have configured JMeter to act as a proxy between Postman and our backend and capture the results. So for benefit of the time, I've already created all these HTTP requests, and I've also ran some of the metrics in JMeter, which I'll be going through in this demo. Firstly, I have run some couple of similar test cases on different concurrent threads to measure the scalability part. I have picked creating a demo user, creating an event, and watching that particular event. So these are my two thread groups. In one of them, I have defined number of threads as 10 and ramp up period as 60. So when I ran this particular controller, I have extracted the JSON for authentication and authorization, and I've placed it inside this. And I've been using it as a token in the headers for other requests. So when I ran this particular controller with all these following requests, so this is the graph result, and this is my result tree. So each of them shows the result and output for all these threads which have been running. So this is my request, and this is the response data, and this is the sampler result, which shows latency and average response time. So let's go over the same. I have run the similar test case setup in thread group 4, which has number of threads as 1000 and ramp up period as 60. So even in this particular result tree, all of them have run, and I have captured the results in the summary report. So let's go over the summary report. So if we look at the summary report, for the 10 threads execution, the throughput was 1.5 per second, and the graph results shows the total throughput being 88.68 per minute. Similarly, if we see for thread group 4, where we ran 1000 concurrent threads, the throughput has increased and it's 7988.41. And this is our summary report. So by Little's law, it states that the average response time times throughput it should be approximately equal to number of threads. And we observe that from between 10 threads and 1000 threads, there has been increase in throughput. But this particular system, we have only changed the core logic, and database still remains as a bottleneck. All the read and write operations are still being done on the database, and the future work would be to include either caching, making replicas of the database, implementing load balancing, and other techniques to increase the scalability portion. To address the scalability part, we also have a ready script of command line, test case reader scripts, and Postman calls, which can be used by any new user who's been hired to the team. So this also helps in the scalability from with people's perspective. So a new developer can be ramped up easily and will be able to support the project. So in scalability, we have tried to do horizontal scalability using multi-threading and stateless nature of REST. There remains future work. If required, this system can be enhanced and supported for caching and load balancing, Lambda and other mechanisms to improve the scalability. Let's go ahead and look at our other enhancement feature. It is authentication and authorization. I have defined 5 roles in our system, which is admin, streaming service rep, studio rep, demo rep, and subscriber. And all of them have different access permissions. So depending on their role, they can perform many things, and admin has access to all the methods. So let me demonstrate this using Postman. This is my create URL, create user API. So admin user has been successfully registered, and I will sign in. And this is the new JWT token which has been generated. And I'll also demonstrate using a subscriber, which is a user who subscribes to streaming service system. He has least privileges. And let me get the JW token for him. So let's see authorization. So authentication was successful and these users were successfully able to sign in into the streaming service system. Now using subscriber JWT token, let me try to check if he has access to create demo. It gives 403 forbidden because this user doesn't have privileges to create a demo, create services, create stream, and so on. But what about the admin user? I'll copy the JWT token from admin and then use it in the create demo. And admin user was successfully able to create demo groups and he'll be able to perform other operations and billing service related stuff.
So going over to the demo section, we have this, you can see the Streaming Wars application, and it follows a layered architecture, and it has controllers which which take in the request, and there are services classes which delegate those, and there are model classes and service implementations that take care of all the requests, and there is a repository that handles the DB interactions and all the CRUD operations. So going forward with the demonstration, we can just run there's a test case reader which takes command line arguments and just does A3 and resolves this. So going with the test case execution. So first of all, sign in happens and it gets the token. And once the token is ready, the command line execution can happen with this. And you can see all the requests are being handled. And you can see the responses here. This acts like a test case as well as demonstration for our application.